Okay, this is concept number 9, which is scatterplots. Now, with scatterplots, a lot of the times the data is graphed for you, sometimes it's not graphed for you, and you have to do that initial part. It just depends on the question that you're given. But it's going to be a graph of data points that you're given that could be scattered all around. They have a lot of different pieces that go into them, a lot of different terminology that you have to be able to use with these. So a scatterplot itself is a graph that shows a relationship between two sets of data. So to make a scatterplot, you're just going to graph the data as ordered pairs, just like you normally would. So for this first example, we're looking at the number of words typed per minute. So your number of words typed are on your x-axis. Your y-axis is the minutes that it takes to type those words. So you're just going to plot these points. So I have now 14 and 5. So 14 minutes, I go to 14 on my x-axis and up to 5 on my y-axis. So it's just plotting points like we've been doing. You do not connect them all though. Okay? If you notice, and they're called scatter plots for a reason, because these points are kind of scattered all around. They're not necessarily in a perfectly straight line, but they do have some sort of a relationship between them. So when we talk about the relationship that's between the two sets of data, that's its correlation. Okay, so the word correlation, which is a really important vocab and terminology with scatterplots, the word correlation simply is looking at their relationship. So we have 3 different types of correlation. We have positive correlation, whereas as one set of the values increases, the other set also increases. Okay, so if we look back at this first example, this would show a positive correlation because as your number of words that you are typing is increasing, generally the time that it's going to take you to type those words is also going to increase. So it's kind of similar to whether or not you have a positive slope or a negative slope. If I look at the direction of these points from the left to the right, it's going in a positive direction. Okay, so as my x values increase, my y values are also increasing. Now, negative correlation is just the opposite. As those one set of values is increasing, the other one tends to decrease. Okay, so maybe as your x values are increasing, your y values are decreasing over time. So it's kind of similar to a negative slope. Then we have a no correlation at all, and this is where there is no actual relationship between the two different sets of data. So they're not increasing, both of them at the same time. There's not one increasing and the other decreasing. They're just all scattered around, and there's no general relationship between the two. So once you have those points plotted, so if we kind of look back at the first example where we were plotting those points, once you have them plotted, most times you're going to need to draw a line of best fit. Okay? Now, because we can't necessarily connect all of these in a straight line, I need to draw what we call the line of best fit, which is a straight line that goes through these points as best as we can. So if the data has a correlation, we can draw a line of best fit. Now, it has to have a correlation. If there's no correlation in the data, then there's no way to do this step of drawing a line of best fit. This line that we're going to draw is a line that best represents that set of data. Okay, so it's not going to go through all of the points because you can't when they're scattered around, but you want to draw a line kind of in the middle of all of those points that best represents the direction that those values are going. So when you're sketching this line of best fit, you want to draw a line where there are an equal or close to equal number of data values above and below the line. Okay, so you want to have, generally, when you draw a line, you want to kind of go right through the middle of all of the points so that you have about the same number of points above the line as you do below the line. Now, these are your steps here for then. Once you have that line drawn, you then have to go back and write the equation of that line. We've done this before. We did this earlier in the year with writing an equation of a line. So most of this is not new. The only new part is actually drawing that line of best fit in. Once you have it drawn in, the writing the equation we've done before. So here are your steps. You're going to draw a line of best fit so that an equal number of data values are above and below your line. When you draw this line, you want to try to get that equal value above and below. A really important step is to draw your line so that it goes through two nice points that are on opposite ends of the graph. So you want to have two nice points that are one from each kind of towards each end of the graph. This will really help you when you're writing your equation. Okay? Now, what's important about these 2 points is they do not have to be actual ordered pairs from the data. So even though it might not go through one of the ordered pairs, it should generally go through, if you can get it through, two nice points where they cross perfectly at. Once you have that line drawn and you know that it's going through two nice points, you're going to use those two nice points to find the slope. So remember, when we find our slope, we're going to list out those two coordinate pairs of x comma y, and then you're going to subtract your y values and divide that by subtracting your x values. Then, once you have that slope, now you're going to have to plug it back in with one of those two original points so that you can solve for b. So we're going to plug it back in into y equals mx plus b. We're going to plug in the slope that we know, and then we will also plug in the x and the y value from one of those 2 points that you just used. Once you have those 3 pieces plugged in, then you can solve that equation for your b value. And then, final step is to take your slope, your answer for your slope, your answer for your b value, and then actually write your equation. So we're writing it back into y equals mx plus b. You're going to fill in the m value that you found. You're going to fill in the b value that you found for your equation. Again, we've done this before. None of this is new for writing an equation of a line. So it's going to have to bring back some of that stuff that we've done earlier in the year in quarter 2. All right, so some examples here. We want to write the equation of a line of best fit using this scatter plot below. So in this case, the scatter plot was given to you. All of the points were on here. However, we had to draw in our own line of best fit. So most times, if the graph is given to you, the line of best fit will not be given to you. Okay? Now, everybody's line of best fit could be slightly different. It should be generally close to the same. However, they could be a little bit different depending on where you draw your line at. So if we look at the line that we drew, okay, so we sketched the line of best fit and identified 2 nice points. Okay? Now again, those 2 nice points could be actual data points from your initial set of data, or they could just be where it crosses your x and your y values nicely. So in this case, one of these nice points is an actual data point. The other one up here where we have it circled is not an actual data point, but that's okay. You can still use that as your nice point. So the points that we used were 4, 1500 and 16, 2500. So those are our 2 nice points. Okay. Now, once we have those 2 nice points, first step is to find the slope. So we take our y2 minus y1. So I'm taking my y values and I'm subtracting them. 2500 minus 1500 divided by, and I subtract my x values. So 16 minus 4. That's going to give me, when I keep reducing my slope, I'm going to get 83.3 repeating. Now, what's really important to remember with scatterplots is a lot of times your slope is not going to work out to be a nice value. Typically in the past, we've always kept our slope as a fraction for rise over run. For scatterplots, it is okay to change it to a decimal. This is really the only time that we are able to change our slope to a decimal form. Okay? Most times it's not going to be a nice number, so you may have to round a little bit. Try to not round too much. If you have 2 or 3 decimal places with your answer, that's better. So just try to not over round them. Now, once we found the slope, step 3 then is now we have to find the b value. Because remember, I need 2 things to write the equation of a line. I need the slope and I need the y-intercept. So I just found my slope. Now I have to plug that back into my y equals mx plus b, with one of my 2 points. So one of these 2 nice points, and it does not matter which one you use, you have to plug in the x and the y value for them. So we chose to use the 4, 1500. So I have y equals mx plus b. I'm going to plug in the y value of 1500 equals my m, which was 83.3 repeating, times my x value plus b. 1500 equals 333.3 plus b when I multiply them, and then it's just solving for b. It's a one-step equation. Subtract your 333.3 to the other side. So we get a b value of 1,166.67. When you get your intercept, make sure that it actually makes sense. Remember, this b value is where your line of best fit should have been crossing the y-axis at. So always go back and actually look at your graph and make sure that your line of best fit is actually crossing where your b value is saying. They should be the same value. Make sure you double check that. Now, step 4 then is to just write the equation of the line, which really isn't a step. It's just taking those 2 pieces that you just found and plugging them back in. So we want to put them into y equals mx plus b form. Well, our slope was 83.3, so that's my m, and I plug in my b value. Either one of these answers is correct. If you wanted to go back and use the fraction slope, you could, or you can leave it as the decimal form for your final answer. Now, most times with scatter plots, there are going to be follow-up questions once you've found that line of best fit. So we want to answer these questions based on the equation that we found and the line of best fit that we drew. So this is asking us approximate the salary of a coach who has been working for 12 years. Now remember, if you're looking back at your chart, your x values were your years of experience. Your y values, it's told you, was your salary. So if I'm trying to figure out the salary, that means I'm looking for my y value. So I'm solving for y. You can use your equation for this. So I have y equals 83.3x plus 1167.67. Well, I know that this coach has been there for 12 years. I'm going to plug that in for my x value. Solve for y. So 83.3 times 12, add your 1166.67. You're going to get a total of about $2,166.67. That's the approximate salary based off of this data that we were given. Okay, so it's just plugging the value in where it should go. Sometimes it's going to go in for x, sometimes it's going to go in for y. It just depends on what information you're given. So make sure you go back to your actual graph and see what your x-axis was representing and what your y-axis was representing. Part B says about how many years of experience does a coach have if they get paid $3,000? So now in this case, I know the salary. I know they're making $3,000. That's my y value. So here I have to plug this in for y and solve this equation for x. When I solve that equation, I subtract my b value to the other side, divide by my 83.3. We get about 21.999, so you can round that and estimate it to be about 22 years they would make $3,000. Just a note down at the bottom, based on how you draw your line of best fit and what 2 points you use, your equation, your line of best fit, some of these answers may be a little bit different than somebody else's. There are a lot of correct answers when it comes to scatter plots. It all depends on that line of best fit. So you just really need to make sure that you're careful when you're drawing that, but be ready for your answers to not perfectly match our answers or to not perfectly match someone else's answers in class that is doing the same problem as you. Okay? But again, this is concept number 9, which is scatter plots.